Somewhere outside Shanghai, a machine the size of a small regional airliner just lifted straight off the ground, hovered, and flew like nothing the aviation world has seen before. It has no runway. It does not need one. It weighs about 11,000 pounds, stretches 56 feet from nose to tail, and carries a wingspan of 66 feet, and it just became the largest flying car ever built on Earth. If that sentence sounds impossible, that is exactly the reaction engineers around the world had when they saw the footage. This is not a rendering. This is not a stage prop rolled out for a trade show photo. This aircraft has already completed real flight tests, in the real sky, above a real Chinese city. And it is only one piece of a much bigger story that is unfolding right now, one that is quietly rewriting what personal and commercial transportation is going to look like for the rest of your life. In this video, we are going to walk through the Chinese flying vehicles that are already flying, already certified, and already being delivered to real customers, building up to the machine that has genuinely stunned people who have spent their entire careers in aerospace. If you want to see where transportation is actually heading, instead of where people guess it is heading, stick around, because none of what you are about to hear is science fiction. It is happening this year. Let's start with the company behind that giant aircraft. It is called AutoFlight, based in Shanghai, and backed financially by the world's largest electric vehicle battery maker. That backing matters, because building a flying vehicle this large is fundamentally a battery problem before it is anything else. AutoFlight named their aircraft Matrix, and unlike almost everything else in this space, it was not designed for one or two people taking a joyride. It was built to carry up to 10 passengers at once, which puts it in a completely different category from the small 2- and 4-seat prototypes that have dominated headlines for the last few years. Picture something closer to a small regional aircraft that skips the runway entirely, lifting straight up like a helicopter before transitioning into forward flight. The company completed a public flight demonstration at a testing facility near Shanghai, with the aircraft rising off the ground, cruising and landing safely in front of observers. That demonstration alone would be a big story on its own. But the real story is what it represents. AutoFlight is not trying to sell you a personal toy. They are trying to build the electric equivalent of a regional airliner, one that can replace short hops between cities without needing an actual airport, a runway, or a control tower, staffed the way modern aviation currently requires. Executives at the company have said they see strong demand not just inside China, but in island nations, mountainous regions, and anywhere the existing road and rail networks struggle to reach. Places where building a new highway would take a decade, but clearing a small landing pad could take a season. That is the quiet part of this story that most people miss. This is not just about looking cool in a viral video. It is about connecting communities that traditional infrastructure has left behind. Now, if the Matrix represents the commercial, mass transit side of this shift, the next company on our list represents the personal side of it, and it might be even more shocking, because it is not a concept anymore. It is a factory. A Chinese company that spun out of one of the country's major electric vehicle makers has spent over a decade quietly developing what they call a modular flying car. The idea works like this. You have a ground vehicle, a 6-wheeled electric platform that drives on regular roads using a standard driver's license. Then, hidden inside or connected to that ground vehicle, there is a detachable 2-seat aircraft. When you want to fly, the aircraft separates from the car, takes off vertically, and carries you into the sky, while the ground vehicle waits behind or continues on its own path. This company recently opened what it calls the world's first mass production line built specifically for flying cars, a facility spanning more than 100,000 square meters in Guangzhou. Trial production has already begun. The company says it is targeting an eventual annual capacity of 10,000 units, with an aircraft rolling off the line roughly every 30 minutes once the factory reaches full speed. As of earlier this year, the company had already logged thousands of reservations, the overwhelming majority from customers inside China, with a smaller but growing number coming from international buyers. The price tag sits under 2 million yuan, which converts to somewhere around 280,000 US dollars. That is expensive by car standards, obviously, but it is remarkably cheap by aircraft standards, and it puts personal flight within reach of a much wider group of buyers than anyone expected this early in the industry's development. The company is currently working through the certification process required before full-scale public deliveries can begin, but trial production units are already being used for flight testing and performance verification, meaning real aircraft built on a real assembly line are already in the air today. Before we move past the Matrix, it is worth sitting with the actual numbers for a second, because they are easy to say quickly and hard to fully picture. 11,000 pounds is roughly the weight of a large delivery truck, except this one does not touch the road once it leaves the ground. A 66-foot wingspan is wider than a lot of regional jets that airlines use for short, domestic hops today. And yet, this aircraft is powered entirely by electric motors and batteries, with no jet fuel and no traditional combustion engine anywhere on board. Getting a machine that heavy off the ground vertically, on batteries alone without a runway, is one of the harder engineering problems in modern aviation, which is exactly why most competing companies around the world have stuck to much smaller, lighter designs carrying 4 to 6 passengers at most. AutoFlight chose to go the opposite direction, betting that the market for genuine mass transit, not just personal joyrides, is where the real long-term money sits. Whether that bet pays off commercially is still an open question, but the engineering bet has already been proven correct, since the aircraft has flown, hovered, and landed exactly as designed in front of independent observers. Let's talk about certification for a moment, because this is the part of the story that separates genuine breakthroughs from flashy prototypes that never go anywhere. Anyone can build something that flies once in a controlled demonstration. Very few companies can get a government aviation authority to officially certify that an aircraft is safe enough to carry paying passengers with no pilot on board. China's aviation regulator has already done exactly that for one specific aircraft. Back in October of 2023, a 2-seat autonomous aircraft built by a Guangzhou-based company received the world's first type certificate ever issued for a passenger-carrying unmanned aerial vehicle. That was the first domino. Since then, the same aircraft went on to receive a standard airworthiness certificate, meaning individual units coming off the production line were confirmed to match the certified design. Then it received approval for fully unpiloted operations, including takeoff and landing without a single person in the loop. And more recently, operators running this aircraft in the cities of Guangzhou and Hefei received official air operator certificates, the same type of license a commercial airline would need to legally sell tickets. That combination makes this the first company on Earth to hold every single layer of certification required to run a pilotless, passenger-carrying commercial air service. Regular citizens in those 2 cities can now literally buy a ticket, walk up to a small aircraft with 16 rotors spread across 8 folding arms, sit down in one of 2 seats, and be flown across the skyline with nobody at the controls, except a ground-based monitoring center watching dozens of data points in real time. The suggested retail price for one of these aircraft is a little over 2 million yuan, but the more interesting number is the ticket price for a ride, since low-altitude sightseeing flights are already being sold to the public as a real, functioning tourism product. Not a demo, not a beta test, an actual paid service running today. The same aircraft has also started showing up well beyond China's borders. It has been used in flight demonstrations in the Middle East, including passenger flights conducted with government transport officials on board in Qatar. It has taken part in sandbox testing programs in Thailand, where regulators flew alongside company staff to evaluate real-world performance. And in Saudi Arabia, a partnership between the manufacturer and local aviation companies is working toward rolling out commercial passenger service across more than 20 airports over the next 2 years, following an initial round of trial flights. What started as a single certified aircraft, flying sightseeing routes in 2 Chinese cities, is quickly turning into an international rollout, with governments across multiple continents deciding that pilotless passenger flight is no longer too risky to greenlight. That is a genuinely remarkable shift in regulatory thinking that happened in just a few short years. So why is all of this happening in China specifically? And why is it happening now instead of 5 or 10 years from now? Part of the answer comes down to national policy. China's central government has formally designated what it calls the low-altitude economy as a strategic emerging industry, baking it directly into the country's latest multi-year development plan. That is not just supportive language in a press release. It translates into real infrastructure spending. Cities like Shenzhen have already built more than 1,000 takeoff and landing points to support small aircraft operations, well ahead of most of these vehicles even reaching full commercial scale. Regulators are actively drafting hundreds of detailed technical standards covering aircraft design, airspace management, and safety requirements, with a goal of having baseline rules finalized within the next couple of years and a much larger, more complete rulebook in place by the end of the decade. In other words, the government is not waiting for the technology to mature and then reacting to it. It is building the roads in the sky before most of the traffic even exists. The same playbook China used with electric vehicle charging infrastructure roughly a decade ago, a strategy that helped its car industry leapfrog competitors who moved more cautiously. There's also a manufacturing advantage at play here that is easy to overlook. Many of these flying vehicle companies did not start from zero. They are either divisions of existing electric vehicle manufacturers, or they are staffed by engineers who spent years building EV motors, battery packs, and software before ever touching an aircraft design. That matters enormously, because the core technology inside a modern electric flying vehicle, the motors, the battery cells, the power management systems, the collision avoidance software, is almost identical to what already exists inside millions of electric cars on Chinese roads today. Instead of inventing an entirely new supply chain from scratch, these companies are borrowing directly from an EV manufacturing base that is already the largest and most cost-efficient in the world. That is a huge part of why prices for these aircraft, while still far from cheap, are dropping into a range that puts personal aviation years ahead of where most industry analysts expected it to be at this point. Let's zoom out and put a few more names on the map, because this is not a story about one lone company getting lucky. It is a genuine industry forming in real time, with multiple serious competitors pushing each other forward. Beyond the two companies we have already covered, at least two other major players are racing through the same certification and production process. One of China's largest EV manufacturers operates its own dedicated flying vehicle division, working towards similar low-altitude commercial applications, aiming to bring aircraft to market on a comparable timeline. Another well-established Chinese automaker has folded flying vehicle development into its broader mobility strategy, treating it as a long-term extension of the same electric powertrain expertise it already uses in its passenger cars. When you have this many serious, well-funded, technically capable companies chasing the same opportunity at the same time, that is usually the signal an industry has moved past the experimental phase and into the early stages of a genuine market. Here is the part that should really change how you think about all of this. A decade ago, if you mentioned flying cars to anyone outside a research lab, you would get a laugh. It sounded like something permanently 20 years away, a promise that showed up at every World's Fair and never actually arrived. Today, there's a fully certified aircraft flying paying passengers on. Scheduled sightseeing routes in 2 Chinese cities, with international expansion already underway. There's a mass production factory built specifically to manufacture personal flying cars, with thousands of orders on the books and vehicles already coming off the line for testing. And there is now the largest flying car ever constructed, already flown, already demonstrated publicly, aimed squarely at replacing short-haul commercial travel between cities that current infrastructure struggles to connect efficiently. None of that is speculative anymore. None of it is a rendering or a concept video. These are physical machines, flying in physical skies, monitored by real regulators who have decided the risk is manageable enough to let regular people on board. What happens next matters just as much as what has already happened. Over the next 2 to 3 years, expect the price of personal flying vehicles to keep dropping as production scales up, the same pattern we saw with electric cars, solar panels, and smartphones before them. Expect more cities, both inside China and beyond, to open dedicated low-altitude flight corridors, as regulators gain confidence in the safety data these aircraft keep generating with every flight. Expect established Western aerospace companies to feel real competitive pressure for the first time, since much of this technology, once mature, tends to spread quickly through licensing deals, joint ventures, and international expansion, the exact same pattern that allowed Chinese electric vehicle technology to show up inside international brands far faster than most people expected. And expect the line between car and aircraft to keep blurring, until owning something that can drive on Monday and fly on Saturday stops sounding like a novelty and starts sounding like a normal, if expensive, option for regular consumers. It is also worth comparing this pace to what is happening in the West, not to dunk on anyone, but because the contrast tells you a lot about why China has jumped ahead so quickly. American and European companies working on similar aircraft have generally focused on the air taxi model, aircraft designed to operate out of dedicated vertiports in major cities, which requires an enormous amount of urban infrastructure, dense air traffic coordination, and years of drawn-out regulatory review before a single paying passenger can climb aboard. That approach is not wrong, but it is slow by nature. China's largest players have taken a different path in 2 directions at once. On one side, companies are targeting individual ownership, selling a product. A private buyer can actually park in a garage, sidestepping the need for citywide vertiport networks entirely. On the other side, companies like AutoFlight are targeting point-to-point routes between smaller cities and regions that never had great transportation links to begin with, which involves far less regulatory friction than trying to fly over a dense downtown core. Both paths avoid the single biggest bottleneck slowing everyone else down, and both are backed by a government actively building the rules and the physical infrastructure ahead of demand instead of waiting to see if demand shows up first. The bigger picture here is simple, even if the technology behind it is not. For most of human history, flight belonged to a small, highly trained group of professionals, and getting off the ground required an airport, a licensed pilot, and a lot of money. What is happening in China right now is the early stage of that barrier coming down, piece by piece, not through one single miracle invention, but through years of steady, unglamorous engineering work across batteries, flight control software, and manufacturing scale, all converging at roughly the same moment. That convergence is exactly why a giant 10-passenger electric aircraft can lift off near Shanghai and fly successfully on one of its very first public tests, why a modular flying car factory can already be producing units meant for real customers, and why regular tourists can already buy a ticket and fly across a city skyline with nobody holding the controls. If you found this breakdown useful, Consider subscribing so you do not miss the next update, because this industry is moving fast enough that a video like this one could look outdated within months. Drop a comment and let me know which of these vehicles surprised you the most. The giant 10-passenger Matrix, the modular car that splits apart mid-trip, or the fully certified aircraft already flying, paying passengers with nobody at the controls. I read through the comments, and I want to know which one of these you would actually be willing to step into first.